All right, let's look at number 35. Oh, you picked a long one. So, consider the graph of y equals negative x squared plus 5. And they even give you a picture of it. Hopefully you could graph negative x squared plus 5 without a picture, because you'd go up 5 and have an upside down parabola. But they spotted you the picture anyway. Part A. Find the equation of the secant line joining the points negative 1, 4 and 2, 1. A equation of a line. So I need a point and a slope. So they gave me 2 points. I can use either one. The slope of a secant line would just be good old algebra 1 stuff. So y2 minus y1 over x2 minus x1. So negative 3 over 3 is negative 1. And then y minus, I'll just use the first point, though it doesn't really matter which point we use. Y minus 4 equals negative 1 times x plus 1. Negative 1, 4, 2, 1. I don't know, it didn't say graph it, but there's the graph of that line. Part B. Use the mean value theorem to determine a point C in the interval from negative 1 to 2 such that the tangent line at C is parallel to the secant line. So that's lots of words, but they want me to find where my calculus slope equals my algebra slope. Because MVT says it will happen somewhere in between there, in between negative 1 and negative 2. It looks like it happens right about there, but let's do some calculus to figure that out. So y prime is negative 2x. Well, let's kind of back up and do it the same order we did yesterday. And that is the MVT just means that the calculus slope somewhere equals the algebra slope over that interval. We already found the algebra slope. That was negative 1. Calculus slope is the derivative. That's negative 2x. So it happens at x equals 1/2. That kind of matches my guess up here. That fits. My graph's not perfect and my line wasn't perfect, but that's reasonable based on my picture there. Let me make sure I answered the right question here. Use the mean value theorem to determine a point C in the interval. So C is just the x value. So that's a little bit confusing. It didn't say the point x comma y. It just said the C value. So x equals 1/2 is where it happens. That's the spot where the calculus slope equals the algebra slope, where the lines are parallel. Part C. Find the equation of the tangent line through C. So I need point and slope again. Well, slope I know is negative 1 because the slope of the secant line is negative 1. The slope of the tangent line is negative 1. I could plug in 1/2 to the derivative to find the slope and I would get negative 1. So I'm good on that front. The point, the x value is 1/2. How am I going to get the y value? Yeah, plug it into the original. Don't plug it into the derivative because the derivative would tell me the slope. Plug it into the original. So that would be 5 minus 1/4. So that would be 4 3/4. If you want to switch to 4.75, that's fine. If you want to switch to, let's see, would that be 19/4? If you want to go that route with it. All of those are equal. They're all acceptable. Usually we don't care in calculus. Whichever one makes the most sense to you is fine. I'll go 19/4, although again, pick any of them. So y minus 19/4, or 4 3/4, or 4.75, equals -1 times x minus a half. That's the line of the tangent line at 1/2. So the calculus line slope is equal to the algebra slope. The rest of the line's not the same, but their slopes are the same. And then lastly, part D, use a graphing utility to graph all of those and kind of show what we just found. Well, I am the graphing utility today, so there's our picture of the secant line, the tangent line, and the graph. And the idea is, well, we can tell that these slopes are equal to each other. So the MVT says that the calculus slope somewhere is equal to the algebra slope over the whole thing. And your job usually is to find the somewhere. Where does that happen? So that's a good question. That's a good overview of MVT.